everybody, thank you so much for listening to this video. I think it'll be very helpful for you when you're reviewing for your Unit 5 test. I can't believe we're already on Unit 5, wow. But just a reminder, your Unit 5 test is going to be due on Tuesday. That is October 28th, and it needs to be turned in by 11:59 p.m. to get credit for it. So that's the 5.07 Unit 5 test. Again, due October 28th by 11:59 p.m. So please make sure you're getting that done. So these are the main objectives that will be covered on the test, and we're going to go through them one by one so that you have a clear understanding of what's going to be covered on the test. Just a reminder, I will be out of the office on Monday and Tuesday. I'll still be answering K-mails, but just periodically because I will be at an educational conference. So if you have questions regarding the test, please make sure you're sending them early so that you're giving me time to respond to you so that you don't miss the deadline for the test. So the first objective on the test I want to go over is recognizing that an element is a substance that cannot be broken down by chemical means. So if you went to break an element down even further, it would no longer have the same properties as that element. So if I attempted to take oxygen and break it down further, it would no longer be oxygen. It would have different properties. We would get down to those electrons, protons, and neutrons. It would not be considered an element anymore. So if it said on your test, like, why is it that nitrogen is considered an element, you would just need to know for this purpose that nitrogen, oxygen, hydrogen, all of those elements on the periodic table cannot be further broken down using chemical means. And so when we're looking at the periodic table, we are seeing this type of figure right here for each of our elements. At the top, you will see the atomic number. Remember, every single element has a unique atomic number, and this talks about the number of protons that are in that element. And so if you change the number of protons, then you are completely changing that element. Then usually found in the center of these squares is the atomic symbol. So this, for carbon, the symbol is C. You'll notice for oxygen, it's O. Nitrogen is N. So every element has a unique symbol that we use just to kind of shorten the name here, because some of those names get extra long. It's just easier also when we're creating equations, chemical equations, to use the symbol rather than use the name, because those chemical equations for molecules would get super, super long otherwise. And then our average atomic mass, which we know down here is the number of protons plus the number of neutrons in that atom. And this can change depending on if it's a regular carbon or nitrogen or oxygen, or if it's an isotope of that element. So here we have the periodic table, and you'll need to know that the periodic tables are arranged into groups and families, and how they get arranged is based on their similarities in their electron structure. So their electron cloud that is located outside of the nucleus is helping them be grouped, and also our main focus for this class is going to be that they're grouped based on their properties. So you can see there's some color coding going on here. We have this purplish color here, which is representing the nonmetals, which are mostly happening down the right side of this, such as our gases over here, our neon gases and things like that. Hydrogen gas up here, those are our nonmetals. We've got our metalloids just right here, this teeny tiny family here, not very many metalloids. And then the biggest group here in the center is all of these metals. That's that kind of olivey green color is representing the metals. So our largest group is metals. And we're going to go into the properties of these, but the way an element gets put into one of these groups is based on its properties. So all of these, even though lithium is much, much, much smaller than, say, cadmium over here, or gold or silver, it's so much smaller because it's all the way up in the top left corner of the periodic table, and as we know, as we get further down, we're getting larger, heavier elements, but it still has very similar properties to all of these elements down here. So as we said before, metals are the largest group on the periodic table, and these have a tendency to release electrons. They like to get rid of their electrons. So as we saw up here, their similarities in their electron structure, whether or not they have a full outer shell, really is what's causing them to have a lot of their similar properties. So metals tend to have not full outer shells, and they want to get rid of one of those electrons so that they have one less electron, leaving them happy with a full outer shell. They'll have less outer shells, but if they get rid of those couple that are in their most outer shell when they're by themselves, then they're happy. And usually these elements are starting on the left, and they make up about 3/4 of the naturally occurring elements. So as you can see here, they start all the way on the left, and then they go fourth, and there's only a couple that are located at the far right corner of the periodic table. So they're mostly on the left middle side. Okay, a nonmetal is electronegative, and they like to attract electrons. So while a metal likes to give electrons away, a nonmetal usually needs more. So it may have an almost full outer electron shell, and it may just need a couple extra electrons to make it happy and fill that outer shell. So it usually is accepting electrons. It attracts those. So it may bond well with a metal because the metal wants to get rid of its electrons. The nonmetal wants to take the electrons, so they would do a really good job bonding with one another. And again, these are on the right of the periodic table, and they only make up about 1/4 of the naturally occurring elements. And then last but not least, we have metalloids. And these are tricky groups because they have both metallic and non-metallic properties. So some of them want to take electrons, and some of them want to give them away. So this is a unique group here, and it makes up just that teeny tiny group right here. Just these few elements. There's 1, 2, 3, 4, 5, 6. These 6 elements here are the metalloids. So, and you can notice here, it's interesting, they're located between the nonmetals and the metals. So we know, except for hydrogen, but we know that these on the periodic table, they're grouped based on their properties. So it makes sense that so the metals are all grouped together, the nonmetals are all grouped together, and then the metalloids, which are somewhat of a combination between the two, are located on the periodic table between the two different main groups. So that should just help encourage you to understand that that the elements are grouped based on their properties on the periodic table. Okay, another requirement for the test is that you're able to recognize that a compound is a pure substance formed from chemical combinations of different elements. So all that a compound is you're taking several elements, they're joining together to form compounds, and we describe compounds by their chemical formulas. So here is an example of a compound. We have 2 different types of elements. We have oxygen, which is an element, and hydrogen, which is an element, and they are bonded together or joined to form the compound, which is, this one is water. And we all know the common chemical formula for water is H2O. So our example here, our chemical, I'll write it here. Our chemical formula is H2O. Okay, and remember, we're using the symbols, like I told you before, we use the symbols here in a chemical formula to make this smaller, because it would be super long if we wrote hydrogen to oxygen. So we use those chemical symbols when we're making formulas. Okay, last but not least, we are going to need to be able to explain the properties of compounds and that they are different from the elements that form them. So this is tricky. So if we look at this compound here, we have oxygen, which has unique properties, and hydrogen, which has unique properties. Hydrogen is up here, it's a nonmetal. Oxygen is also a nonmetal over here, but it's going to have some different properties because it's larger. Oxygen's larger than hydrogen. So even though oxygen and hydrogen have very different properties from one another, when they're joined together, the compound is actually going to have a completely different property than the two individual elements that made it. So for example, salt. If you ate Na, which is sodium, or Cl, which is chlorine, like what we put in our pools to kill off germs and bacteria and things like that, if you ate either of those separately, it would actually kill you. Okay, they're toxic. But when you combine them into a compound, NaCl, then you get table salt, which you put on your food and you're able to eat that, and it's not toxic for you. This should be H2O, sorry about that. And then sugar also, these S's are, I don't know what's going on with these, ignore these chemical or equations, but so sugar, salt, all of those have different or elements that make them up that have, and then they end up with different properties that are unique to the compound once those two or three or four or however many elements combine to make the compound. So when they combine, the atom of each element loses its unique property. So if it was a metal and it was metallic and a good conductor of electricity, it would lose those properties once it was formed into the compound, because the compound is pure, it's unique, and it creates its own properties when combined. So those are the main things you're going to need to know for the Unit 5 test. Again, one last reminder that the test is due at 11:59 on Tuesday, October 28th, so please don't forget. Please make sure that you've studied hard for it and that you are watching this video over again if you feel you're having trouble. I would highly recommend going back through each of your lessons in Unit 5 and just kind of skimming through to make sure you grasp a good understanding of everything. So I look forward to seeing you guys in our Class Connect session next Tuesday. So we'll already be in November then. Wow. So I'll see you guys Tuesday, November 4th. Again, if you have questions, comments, concerns, send me a K-mail. Try to send it early because, again, Monday and Tuesday I'll take a little longer to respond than normal. So I want to make sure I'm answering your questions if you need them answered in a timely fashion. So don't send me a K-mail, please, at night on Tuesday and expect a quick answer about the test. So you'll need to make sure you're logging in Tuesday early in the day, trying to take the test, and if you have questions from there, you're giving me time to be able to get back to you. So again, have a good day. Good luck on your test. I know you guys will do great.